Hello, everybody, and welcome to this week's lesson. This week, we are just doing a review of our lessons from July and August. So this video is for you if you have worked on the lessons and assignments on our Google Classroom from July and August, and you're ready to see how much you remember from those lessons. All right, so we're going to start off with a couple of announcements here. So our hybrid classes start August 17th. I sent out two things over Remind this morning, actually, Monday this morning. I sent out a guide to hybrid classes handout to each class. Those guides are also accessible on our Google Classroom. And then I sent out a link to a video announcement where I talk in detail about the hybrid classes, how they're going to work, and I go over the information that's in the guide to hybrid classes. Everybody needs to fill out registration paperwork for our new school year. I sent out messages to each of you individually, those of you who still need to fill out paperwork. So if you didn't get a message from me, that means you've already filled out your paperwork or you're a new student and you already went through the registration process. You can fill out the paperwork whenever it fits into your schedule. Our building is open Monday through Thursday, 8 a.m. to 8 p.m. and then on Fridays from 8 a.m. to 4 p.m. When you go to fill out the paperwork, you just tell them that you're a returning student, you tell them my name, and you tell them you just need to fill out paperwork. You do not need an appointment, you just need to fill out paperwork. And also make sure you sign everywhere it asks you to sign. You can also ask the person at the front desk to double check your paperwork for you, because there's a couple papers in there that the signature is really important, and if you don't sign it, then we're going to have to figure out a way for you to come back and sign the papers again. So just make sure you're careful when you're going through the paperwork. This week we are doing review. The plan is that next week, the week of August 17th, we're going to be sort of restarting our math units. So kind of going back to fundamentals, back to basics, and working our way upwards from there. And just a reminder that GED ready testing can be done at home or at our building. So if you have a computer at home, you can do it at home. And you can do GED testing as soon as you are registered for the new year. And also a reminder that GED testing appointments are open. The testing center at Leestown is open for appointments. All right, so by the end of this week, you will remember how to solve real-world problems involving linear equations and inequalities, compare properties of two linear or quadratic equations, each represented in a different way, solve multi-step real-world arithmetic problems using ratios or proportions, including those that require converting units of measure, and use the Pythagorean theorem to determine unknown side lengths in a right triangle. So this is a list of kind of the key points that we've covered in July and August with our lessons. So last week and the week before, we practiced writing and solving linear equations and inequalities. The weeks before that, we worked on comparing functions. So comparing linear and quadratic functions. We also worked on solving problems with ratios and proportions. And we practiced using the Pythagorean theorem. So those are kind of the key points that we covered in July and August. So again, this week is all about review. That means that this lesson right here, this video, should not be the first time you're learning these skills, right? This lesson is for you if you have worked on the lessons from July and August already and you're ready to test and see how much you remember from those. So if you haven't already, be sure to go through July and August lessons and assignments on our Google Classroom. And here I have listed for you the weeks in July and August and what the topic was for each week. All right, so what we're going to do today is we're going to go through 6 problems. that I just pulled straight from these lessons listed here. So if you've already watched those lessons or attended those lessons with me, these problems should seem familiar to you. All right, so starting off with number 1, the Pythagorean theorem. A 15-foot ladder is placed 5 feet away from a wall. How high up the wall does the ladder reach? All right, so if we think about this situation, the ladder is creating a right triangle with the side of this building, right? So we've got the ladder, we've got the ground, and we've got the wall that are forming a triangle. You've got 3 sides, and it's a right triangle, right? As long as your building isn't leaning over, you've got a right triangle. So hopefully it's a nice sturdy building that's not tilting over to one side. So we've got a right triangle here. We know the ladder is 15 feet. So this side of our triangle here is 15 feet. This is the hypotenuse, or the longest side of our right triangle. And we know that because it's across from the right angle here. So the hypotenuse of this triangle is 15 feet. And then we know one of the shorter sides. We know that this side down here is 5 feet. We want to know how high up the wall does the ladder reach. So we are looking for this side here. And I'm going to call this side A for now, just to give it a name, side A. So when we have a problem where we've got a right triangle and we know 2 of the sides, but we're missing a 3rd side, we know that we should use the Pythagorean theorem to help us solve the problem. So this can be found on your formula sheet. If you look at your formula sheet for the Pythagorean theorem, you will find an equation that says a squared plus b squared equals c squared. So again, that is probably 3/4 of the way down your GED math formula sheet. All right, so what the Pythagorean theorem is saying is it's saying the sum of the squares of the 2 shorter sides is equal to the square of the longer side. So the sum of the squares of the 2 legs is equal to the square of the hypotenuse, the longest side. So we've got our formula written down here, and I'm going to go ahead and just start filling in the information we know. So we know what C is. C is always the hypotenuse. It's always the longest side. So we know what this is. And here with A and B, it doesn't really matter like which one, for the 2 shorter sides, the 2 legs, doesn't really matter which one you say is which, but in this particular case, I just said A is the unknown side, so we'll say we know what B is. B is 5. And then I'll keep that A there as a placeholder. Okay, so we're gonna use this equation to help us solve for A, to help us figure out what that missing side length is. I'm gonna go ahead and I'm gonna evaluate the exponents. I'm not going to evaluate A squared because I don't know what A is yet, so I can't square it. But 5 squared, right? 5 squared means 5 times 5, which is 25. And 15 squared means 15 times 15, which is 225. Okay, so we're saying now that something plus 25 equals 225. So you might be able to figure out in your head what this A squared has to represent, right? Something plus 25 equals 225. Well, that something has to be 200, right? 200 plus 25 equals 225. But if you're not sure, you can subtract. So if A squared plus 25 equals 225, then we know that A squared is going to be equal to 225 minus 25. That comes back to our discussion about inverse operations and solving equations. All right, so 225 minus 25 is 200. So a squared is equal to 200. So we are almost there, but not quite, because we want to know what a is, right? We don't just want to know what a squared is, right? This ladder is definitely not reaching 200 feet up the wall here, right? So this is not our final answer. The last thing we do, if a squared is 200, then to determine what a is, we need to take the square root of 200. Remember that squaring and square roots are inverse operations. They sort of undo each other, just like multiplication and division and addition and subtraction. So we undo that squaring with the square root, and the square root of 200. This is something to get out your calculator for. So I'm going to do second x squared 200, enter. So I'm getting a decimal number. It says 14.14213562. So lots of decimals there. Now in this problem, I didn't give you instructions on how to round. So it's actually up to you how you would like to round your answer. Typically on the GED, you're going to see them asking you to round either to the nearest whole number, to the nearest tenth, or the nearest hundredth. So let's go ahead and let's round our answer to the nearest tenth. So rounding our answer to the nearest tenth, if we have 14.14 to the nearest tenth, that's going to round to 14.1. So the ladder is going to reach approximately 14.1 feet up the wall. And that's our answer. So again, I took this lesson directly from our lesson at the beginning of July on the Pythagorean theorem. So you definitely want to go back and take a second look at that lesson if you had a little bit of trouble with this problem, or if you would like to see this problem again, because like I said, I went into it in depth in the original lesson. All right, number 2, ratios and proportions. For an art project, Constantine is making a scale model of his bedroom. His actual room is 15 feet long and 12 feet wide. In the model, the room is 5 inches long. How wide should the model be? Okay, so Constantine is making a scale model of his bedroom. So he's making like a miniature model of his bedroom that looks exactly like his real bedroom. So if you're making a scale model of something, you want to keep all of the proportions the same. Right? So even though it's not actually the same size, all of the relationships between the different like lengths and widths and heights between all the stuff is the same. So let's start by drawing a picture of the situation here. So his room in real life, if you imagine me here drawing a gigantic rectangle the size of a room. So it is 15 feet long and it is 12 feet wide. And now his scale model that he's making is much smaller than his actual room. This is just going to look a little bit smaller. So that scale model is 5 inches long. And we want to know how wide is it. So I'm just going to put a W here to show that that width is missing. Okay, so the question is, what is that missing width? There's a couple different ways that we can think about it. One way to figure this out is to determine the scale factor. So determine by how much have we multiplied or divided to get to this model. So if I look at corresponding sides in the actual room and the model, so if I look at the length of his bedroom and then the length of the model, well, to get the length of the model, what we would need to do is we would need to divide by 3. So you can think of that as kind of like the scale factor. This is, we're dividing by 3 here. So that means we would need to make the same change. You would need to make the same change to the width, right? If we're gonna divide the length by 3, we're also gonna need to divide the width by 3. So by this method, we see that the width should equal 4 inches. And notice that there's a unit change here as well, right? We're going from feet to inches. Because a 5-foot by 4-foot model would not really be all that miniature. Be like a little playhouse more than a miniature model. Okay, so the width here should be 4 inches. So that's one way we can do it. And this way works nicely just if you're working with easy numbers, right? It's easy to take a look at 15 and 5 and think, oh, well, I would have had to divide by 3. And then it's easy for us to do 12 divided by 3. Sometimes you might have a problem where the numbers aren't so easy. You can't just look at them and be like, oh, multiply by 2, divide by 3, multiply by 6, whatever it is. So in that case, we have a strategy that we can use where we can write and we can solve. So write and solve a proportion. So let's take a second to review our vocabulary here. What is a ratio? So a ratio is a comparison between two numbers. Anytime you're making a comparison between two amounts, that's a ratio. A proportion is two ratios, so two comparisons that are equivalent. So they might look different, but they actually are talking about the same amount of stuff. So when we talk about equivalent fractions, another way to think of that is that we're talking about proportions. So for example, if you and I both order small pizzas that are the same size, if I eat half of my pizza and you eat 2/4 of your pizza, we've eaten the same amount of pizza. So 1 to 2, 1/2, means the same thing as 2 to 4, 2/4. Okay, so we're going to use a proportion here to help us solve for that missing value. First thing we do is we need to write our proportion. So when you're writing a proportion, you start by thinking about what are the two things you're comparing here. So in this problem, we are comparing length and width. Right, both in the actual bedroom and the scale model, the two measurements, the two things we're comparing are length and width. Now, we're going to start filling in the numbers that we know. So in the actual room, the length is 15 and the width is 12. And in the scale model, the length is 5 and the width is unknown. So I'll just put W there for width. Okay, so we have written our proportion there. It's important that we use this guide that we set up, right? We're comparing length to width. We use this guide for both of the ratios that we're writing. So our ratios shouldn't be like flip-flopped. Okay, so now we have our proportion. Now we're gonna solve for this missing piece. The way we solve for it is we take advantage of a characteristic that all proportions have. So if something is a proportion, then its cross products will always be equal to each other. That's just basically the definition of a proportion. So in a proportion, the cross products, when you cross multiply, when you multiply on the diagonal, those numbers must be equal. So here, what that means is that when we do 12 times 5, right, multiplying across, we do 12 times 5, that should be equal to whatever we get when we do 15 times W. Those two things should be equal to each other. Let's go ahead and do as much of this calculation as we can, right? We can figure out 12 times 15, that's equal to 60. So now we're saying 60 is equal to 15 times some number. Now you might know that number off the top of your head. You might know it's 4, but let's say you don't know, you're still a little unsure. Well, to figure out what that W is, we're going to do the inverse of multiplying, right? We are going to divide. So if 15 times W is equal to 60, that means 60 divided by 15 is equal to W. So W, or the width, must be 4. So when we're solving a proportion, there's 2 basic parts to it. First thing we do is we cross multiply. So we did like 12 times 5 is 60. Cross multiply. And then the second main step, oh, forgot my L there, multiply. The second main step there is dividing. So we cross multiply, forgot my L again. Cross multiply and then divide to find that missing 4th number. So that was 2 different strategies for finding a missing number when we're talking about a proportional relationship. The first strategy, we were just thinking about what are we multiplying all of the numbers by, or what are we dividing all of the numbers by to get to the scale model, right? And we saw, well, 15 is getting divided by 3 to get to 5, so we'd have to do the same thing to the 12. That works nicely if you're dealing with small numbers that are easy to multiply and divide together. But if the numbers aren't like that, another way you can solve a problem like this is by writing a proportion and then solving it for the missing value. The way you identify a proportion type problem is the problem will be making a comparison between 2 things. So in this case, it was length and width. And you will be given 3 numbers. So you will be given 3 numbers and you'll be asked to find the 4th. So comparing 2 things, and then you've got a proportion like this where you've got 2 numbers and then a 3rd number and you're missing the 4th number. So that's one way to start getting a feel for what makes a problem a proportion problem. All right, on to the next one. Evaluating and comparing functions. So this is a question that we've actually seen a couple of times now. I went through this question in the lesson on evaluating and comparing functions, but then we also did this as a warm-up question in our linear equations lesson. So if you've been following along with all the lessons, you've actually seen this problem twice now. If you haven't seen this problem yet, then again, I highly, highly, highly recommend you go back and look at the evaluating and comparing functions lesson. I chose this problem because it really uses almost all of the ideas that we talked about in that lesson. So this is a really nice problem for reviewing. All right, so it says, which statement is true about the 2 functions shown below? So we've got f of x shown in the graph here. And we've got g of x shown in the table. So let's look through our choices here. F of x and g of x have the same y-intercept. F of x and g of x have different y-intercepts. F of x has a higher rate of change. What's another word for rate of change? Slope. And then g of x is a quadratic function and f of x is linear. So comparing quadratic versus linear. Okay, so what I just did here is I went through and I underlined some of the key concepts that we went over in that comparing functions lesson. So again, if you haven't seen these before, if you're feeling a little shaky on them, go back and look at that lesson. Do it. All right, so choice A and choice B are both talking about y-intercepts. So are they the same or are they different? So I think we should go ahead and start off by figuring out what the y-intercepts are for f of x and g of x. So let's take a look at the graph. The y-intercept means where does the graph intercept or cross the y-axis. So, right, we've got our horizontal axis, here's the x-axis, we've got our vertical axis, here is the y-axis. So where does this function cross the y-axis? Well, it crosses right here at -2. So the y-intercept of f of x is -2. So we'll say the y-intercept I'll abbreviate it, just y-int for f of x is -2. And let's also think about what's the point that the y-intercept is at here. So what's the coordinate pair for this purple point, the x and y coordinates? Well, the y coordinate is definitely -2, right? Because we just said that's where it's crossing, that's where it's touching the y-axis. What about the x coordinate? Well, if we look at where this point is lined up along the x-axis, it is lined up with 0, right? It's not over at 1, it's not over at -1, it's right there lined up with 0. So this will always be the case for any y-intercept. Y-intercept means the x value must be 0. So one way to identify the y-intercept is to look for x values of 0. So keeping that fact in mind, let's take a look at g of x. So we've got our inputs here, the x values. We've got our outputs here, the g of x values, otherwise known as y values. So taking a look at these coordinate pairs, so the first one is 0, -2. The second one is 1, 2. So looking at this list of coordinate pairs, are we given the y-intercept for g of x? Yes, we are, right? We see the very first coordinate pair in this table has an x value of 0. So this is the point 0, -2. That means the function g of x also crosses the y-axis at this same purple point on the graph. Now, it might not be, if we were to plot out all of these points on the graph, g of x might not totally line up with f of x, but it does line up at this one point at least. So what we just discovered is that f of x and g of x have the same y-intercept. They both cross the y-axis at -2. Now, in the previous lessons that I just talked about, I do go through these other answer choices here and talk about how we identify these things and how we know that they're not the correct answers for this particular question. So definitely go back and check those out if you want some extra review. All right, on to equations. So writing and solving one variable linear equations. Number 4, Tori is planning to sell some t-shirts in her store. The following equation shows how much she'll have to pay for the shirts based on the number of shirts she orders from the supplier. And that equation is C equals 599 plus 150T. If Tori can pay $80.99 for the shirts, how many shirts can she order? All right, so this problem says the following equation shows how much she'll have to pay for the shirts. So I think we can assume that C here means how much she has to pay or the cost of the shirts. So the cost of the shirts is equal So it says based on the number of shirts she orders from the supplier. So right, her cost is going to be affected by the number of shirts she orders, or the number of t-shirts she orders. That's what T stands for in this equation. So the cost is equal to $5.99 plus 150 times T. So let's think about what these dollar amounts mean. So $1.50 times the number of shirts she orders. So $1.50 is the cost per shirt. Cost per shirt. And then this $5.99 is probably some kind of shipping and handling fee, I would guess. So however many shirts she orders, the way you would calculate the total cost would be 150 times the number of shirts plus that $5.99 shipping fee. Okay, and then we are told she can pay $80.99. So that is the cost that she is able to cover. So if she does that, how many shirts can she order? I'm going to take this equation, I'm going to fill in that piece of information. So I'm going to fill in the cost. And when I do that, I will have a one variable equation. I will just have a single variable, a single missing number that I can solve for. So I've got this equation, and now I can solve for the number of t-shirts she can order, right? I can solve to answer the question, how many shirts can she order? So when we're solving a one variable linear equation, we focus always on the side that contains the variable. So here we see the right side of the equation contains the variable. It is our goal to cancel out everything we see over there except for the variable. We want to isolate the variable and get it by itself. In this case, I see we've got addition. We've also got multiplication with the variable. Right, so 150 is being multiplied with T, and then 5.99 is being added with T. We want to get rid of the addition first. We want to cancel out that addition before we cancel out the multiplication. We're kind of working furthest from the variable to closest to the variable. All right, so I'm going to go ahead and cancel out this 5.99 by subtracting. Right, 5.99 minus 5.99 is 0, so that will disappear. And whatever I do to one side of the equation, I must do to the other side. Same thing to both sides. Bring down my equal sign. Over here I have 75. And over here I have 150. 150T. Okay. And so now to cancel out this multiplication, right, 150 times T, to cancel out that multiplication, I'm going to divide. Divide both sides by 150. And so I'm left with T is equal to 50, right? 75 divided by 1.5, or $1.50 is going to be 50. So she can, for a cost of $80.99, she can order 50 t-shirts. All right, let's take a look at number 5. So number 5 says 30 is equal to the sum of 6 and twice an unknown number. What is the unknown number? So this particular problem is not really talking about like a real world situation. This is more of a number riddle that we need to figure out. And when you get a problem like this, where it's not referencing like any people or costs or measurements or anything like that, it's just giving you like a number riddle, probably what you're going to need to do is you're going to need to translate the words into our mathematical language, right? So we're going to take that English sentence, 30 is equal to the sum of 6 and twice an unknown number. And we're going to translate it into a mathematical sentence, into an equation that we can then solve for this unknown number. For this problem especially, you might find it helpful to have your keywords handout next to you. So that's from your welcome packet. Okay, so first thing I notice is this says 30 is equal to, right, is equal to. That means an equal sign. So 30 is equal to. And then it says the sum of 6 and twice an unknown number. Sum means addition. When we talk about summing things or the sum, that means we are talking about addition, adding things together. So the sum of 6 and something else, right? The sum of 6 and this other stuff. So the sum of 6 and twice an unknown number. Twice something means 2 times that thing. It's multiplication. So 2 times an unknown number, I can write that as 2n, right? That means 2 times some number. You could choose any letter you want to. The world is your oyster. Okay, so now we have an equation to solve, and this is actually a really similar equation to the one we just solved, because we see on one side we've got a single number, and then on the right side we've got addition and multiplication that we need to cancel out. So we're going to go through the same steps that we just went through. I'm going to cancel out that plus 6 by taking it away from both sides. 2n remaining over here, and I've got 24 remaining over here. So now we see that 24 is equal to 2 times some number. Now you might be able to figure out what that number is off the top of your head, but let's go through the steps anyway. So I want to cancel out that multiplication, and I use division. Same thing to both sides. And I'm left with n is equal to 12. So that unknown number is 12. That means 30 is equal to the sum of 6 and twice 12. 2 times 12. All right, guys, and we're going to go on to our last review problem here. So this one is from our lesson on inequalities from last week. And I chose this problem because it goes through the main skills that we practiced last week. So writing, solving, and graphing inequalities. Ronaldo is purchasing face masks for his business. He may spend no more than $100. Masks are 50 cents each plus $20 shipping. First, write an inequality representing the number of masks n that Ronaldo can purchase. So that's telling us that we want to use the letter n in our inequality. Then solve the inequality. Finally, graph the solution on a number line. All right, we'll start with the first task here. Write an inequality representing the number of masks and that Ronaldo can purchase. So let's go back into the information we're given. It says he may spend no more than $100. So no more than. In our lesson on inequalities, we talked about keywords that we might see and what they mean in terms of choosing the inequality symbol. So no more than means it could be less than $100, it could be equal to $100, it just can't be more than $100. So we are talking about the amount he spends. The amount he spends needs to be less than or equal to $100. So now let's think about what goes into the amount he spends. Well, masks are 50 cents each plus $20 shipping. So depending on the number of masks he orders, right, it would be 50 cents times the number of masks. I'm just going to write that as 0.5. Means the same thing as 0.50. So 0.5, 50 cents times the number of masks. And then he also is going to have to pay that $20 in shipping. Okay. So we have just written our inequality. This inequality is describing the relationship between the amount of money he can spend and how that cost is totaled up. What are the different components of that cost? And our variable is the number of masks that he can purchase. So that's what we're going to solve for in the next step. I'm going to change colors here just so that we are moving on. All right, and again, I see that we've got a very similar inequality to the equations we just looked at, where on one side of the inequality, we just got this number. And then on the other side, we've got our variable with multiplication and addition. So hopefully by now, you know which one we're going to tackle first. We're going to tackle the addition first. So I'm going to subtract 20 from both sides of the inequality. And that's going to leave me with 8 over here. And 50 cents times the number of masks over here. So 50 cents times the number of masks must be less than or equal to $80. That makes sense, right? Because what we basically just did was we said, okay, so if we kind of account for the shipping costs, what is the amount we have left to actually spend on masks? All right, and now the last step, get rid of that 50 cents by dividing. Divide both sides by 50 cents. Left with the number of masks is less than or equal to 80 divided by 0.5, which is 160. Right? If you have $80 and each mask costs half a dollar, that means you can get up to 160 masks. Okay, so we just solved that inequality. And now our final step is to graph the solution on a number line. So I'm going to set up my number line here. We're talking about the number 160. And now you can fill in some other numbers to the right and to the left of 160, but it's not totally necessary because we know that to the left of 160, we've got smaller numbers, so going down. And then to the right of 160, we've got larger numbers, so going up. Okay, so we want to graph this solution on here. So it's a less than or equal to. That means I'm going to put a dot at 160 and I'm going to fill it in to show that 160 is included in my solution, right? It can be, the number can be equal to 160. And now I'm going to use an arrow to show all the other numbers that are also included. So we're talking about numbers less than or equal to 160. So I want to point to all of those numbers less than 160. Right? If my arrow was going to the right, I would be pointing to all of the numbers more than 160. And that is the graph of our solution. Okay, so thanks for joining me in this video. Your to-do list for this week. I want you to make sure you watch that video announcement and read the guide to hybrid classes. I want you to know exactly what you need to do starting next week. So starting August 17th, I want you to know exactly what's expected of you and exactly what you need to be doing when. So please, please, please watch the video and read the guide. And then if you have questions, let me know. Get in touch with me. Either by email, remind message, you can give me a call, any of those things are fine. So because this is a review week, we don't have quite as many things to take care of this week as we usually do because I want you to spend your time going back over the lessons. So on Monday, I put up the introduction post and also the vocabulary list and online learning links post. That vocabulary list and online learning links post basically just points you to the previous week, so there's no new material in there. On Wednesday, I will be putting up a worksheet Wednesday assignment. That's just kind of a combo of all the different skills we're reviewing this week. On Thursday, I will put up a study skills post. And then on Friday, I would like you to start having a good weekend. So I will hopefully talk to all of you soon. I hope you are excited for the start of hybrid classes, because that means we will get to be seeing a little bit more of each other face to face. And I hope you have a great week. Talk to you soon.